So here's part two of trying to get our heads wrapped around this whole thing about logs and negative logs and pH and stuff like that. So in the previous part one, I showed you how to work with logs and negative logs with nice numbers like 0.01, 0.0001, 0.00001. So now the question is, what about weird numbers? Because usually we get weird numbers that aren't just things that start or finish in the number with the numeral 1. So here we go. Let's take a look at that. So here's a quick review of some of the numbers and the patterns behind the decimal way of expressing a number, and then taking a look at its negative log or its log values sitting right in here. So now let's ask a question. Okay, well, what if we have like a more realistic number, something let's say 0.000, I don't know, 004. Or maybe 0.0000047, some number like that. So what would the and suppose that was the H concentration, so what would we do for the pH? Well, bearing in mind that P means we're taking the negative of the log, let's just kind of deconstruct this. So I notice right in here that this number has, let's see, 1, 2, 3, 4, 5, 6, 7 decimal point shift. So this number is the same as 4.7 times 10 to the minus 7. And actually, I'm just going to use Excel to force this to show me that in scientific notation, and great. So notice that even though sitting up in here I typed in 0.00007, I've forced Excel to basically produce it this way, or show it this way. Now the reason I like this is because this tells me that the negative log value should be somewhere around -7. Well, it would be -7 if it was a nice easy number like 1, but it's not 1, it's 4. So that's a little bit more than 10 to the -7. So, or sorry, it's a little bit more than 1 times 10 to the -7. In fact, it's about 4.7 times bigger than that. So we have this number is more than this number, and I'll just type that in right here. So if we go 0.1234567, so we're going to compare this number to this number. Now the second number is bigger. Now, so we would know that if this has going to have a pH of 7. So sorry, that's just formatting and kind of goofy, so I'm just going to change the formatting on this. Change the formatting on all of these. Great, and I'll make it look great. Okay, so I know that the negative of the log, or the exponent on this, is going to be 7. So now I'm looking at this and I'm asking myself, so do I expect this to have a negative or a log value or whatever greater than 7 or less than 7? So listen for how I work through that. I know that this number is bigger than this number. Okay, and now I look up at this pattern right up in here. I know that this number is bigger than this number. And I know a lot of people make the mistake and say, no, this number's bigger. And look, it's got more decimal points. It's got decimal points in the wrong way. And a better way to think about that is, let's use these words down in here and ask ourselves, would you rather have 1/10 of $1,000,000 or 100th of $1,000,000? Would you rather have 1/10? Let's say you're really hungry and there's a big piece of pie, and there's a big pie. Would you rather have 1/10 of that pie or 100th of that pie? Well, if you're really hungry, you'd rather have 1/10, because you know that 1/10 is bigger than 100th. Similarly, would you rather have 1/10 of a lottery ticket or 1,000th of a lottery ticket? And you'd probably want to have more. So we know that this number is bigger than this number. Okay, back over to here. So we know that this number, just looking, we know that this number is bigger than this number. So I want a number that has bigger, that is associated with bigger. Now that doesn't mean that you want this to be bigger, because look, 7 is sitting in here. So we're going bigger across here, which means bigger across here. See, the bigger the number, the smaller the p-value. So we would expect this to have a p-value of a little bit less. So now let's use Excel, and we'll just take the log of this number right in here, and I'll hit enter, and it says 6 point whatever. Oh, wait a second, how come this says, well, alright, remember it's the negative of that, so I need to take the negative of this. So ignoring the negative, what I want you to see is that the p-value for this would be 6.3. And that makes sense because 0.0001 here, and we have something here that's 4 times bigger. So bigger would mean leaning down in this direction. So we would expect a number to be somewhere in around here, and it is. It's 6.32. So now we'll try one more. What about 0.001 versus something that's like 5 times bigger, 0.005? So we know that this is going to have a p-value. The exponent's going to be -3. We know that the regular exponent, or the p-value, is going to be 3. Sorry, it's going to be 3. So in here, we would expect a number to be bigger than this. All right, let's just try this. 0.01. 0.01, that's 100th, and that number right here, 0.01, is bigger than this number. I know that this is going to have an exponent of -2, and I know it's going to be 2 in here. So I would expect this, because 0.05 is bigger than this and smaller than this, I would expect a p, or a log value, somewhere in between 2 and 3. So now I'll type in, and I'll practice with my spreadsheet, and I'll just say go get the log of that, and go take the negative log, which happens to be just multiplied by -1 on that, and you can see it's 2.3. So how do we figure out, or how do we kind of get a handle on weird numbers that don't end in just 1? Well, the way we do it is we bracket these two numbers in here. So let's say our number is 0.0005. Notice how we get a bracket. We do something that has a 1 here and something that's a little bit bigger, and then we get a handle on the idea that this number is going to be somewhere between here and between here, and that's how we double check or make sure that we're on the right track. Alright, hope that helps.